Hey all, welcome to the second hour of the DC Python Meetup on July 31st. Apologies to all for missing the first hour. We've stopped using Zoom. I'm using Google Meetup, and I've got OBS here recording my desktop window. Metabob just finished giving an awesome presentation on the technology behind their AI-assisted debugging tool, which is VC funded. We did around the rooms, and I'll just briefly mention that I'm always fascinated and entertained by the variety of folks that we get joining and talking about what they're doing with Python, including people looking for jobs, including people who aren't technical who just want to observe, including people that are all over the world. So great again to have that, and we'll have more of that in the future. Now that I've figured out this setup, and I'm doing last Saturday of the month every month for the rest of the year at least. And with that, Metabob, any part twos you want to get into in the second hour?
Yeah. So since we basically covered the overall technology and gave up some of our demo, I guess now we can talk about a bit of the technologies we leverage, at least Python-wise, when it comes to setting up the ETL. I guess, or as well as some of the other technologies that we use, just overall. A lot of it is being done within our application space within AWS. So I'll probably just give you like a brief infrastructure overview to some degree.
Cool.
Uh, so so AWS is definitely convenient. I'm not like the hugest fan of being vendor locked though, so we do use Kubernetes for most of our application stack. But for things in the ETL pipeline, it's just a lot more straightforward to just provision a particular machine to run on AWS. So you'd like provision either a set of machines to run in concert or like a single one to get set up. And what we usually do is we have like a startup script that we operate in Terraform, which is another non-Python tool. But basically, Terraform is infrastructure as code, I guess you could say. And what it does is it allows you to define things in AWS. So like, oh, I need 3 machines. These machines need to be running this operating system. And then every time I start one of these machines, it needs to run this script, install these dependencies, get everything set up. So like I was mentioning earlier with Docker, this is like an even more generalized version of that. So you can do it to multiple different like cloud platforms at the same time. So with this, you can like define something to run within the cloud, but behind the scenes, basically, whether you want to run this program in AWS or GCP or Azure or wherever, they'll handle the actual API calls to create the machine and run the code. All you need to do is just define what needs to run and how many machines and what the machine specifications are, and you're good to go. So we do that for AWS to provision like additional like machine learning instances that we do to run the actual training of our machine learning model, of our AI models. As mentioned earlier, we have multiple ones of them that have different requirements and that feed in all from a central database that we are running in the backend. So this is currently Postgres, and what we do is as we collect data, which is yet another machine that's running in AWS, we have a set of like data scraping utilities that go to GitHub, Bitbucket, and GitLab, and like look for particular Python projects that have been recently worked on to get all of the new like updates, whether or not there's a new pull request, what code was changed, and like to then run that operation. It will then send this information about which repositories need to be looked at again to Redis, which is a in-memory database, but we're actually just using it more as a message queue server. So from that, basically, you would send messages to Redis about, oh, you need to check out the Avi's transit repository. It's been updated, yes, during like last week from the last time we saw it. It's been updated 3 times. It's seen these 3 pull requests that were added, and now we need to see what code changes were made and adapt or like parse the additional information from that model. So we would then pass that over to our into Redis, and then one of the machines that are listening to Redis to find that there's more work to do will see that, oh, there's a new job. Now I need to go execute that job, and so it will then go collect all the necessary metadata for my, or like, let's say, a certain repository, pull that repository's data from GitHub, because we're only looking at open source repositories, so all of that information is publicly available. Then what we do is we need to clean it up. So we pull the stuff there, we get the latest commit, and then we need to calculate all of the diffs between the previous change, go through and then like parse the code base, as well as take all of the language components and filter that through our machine learning model, so we can classify it as both either buggy or non-buggy, and or as what kind of bug it is if it is a bug. So in the order of operations, what we're doing is we're looking for code changes, we're classifying it as a particular bug category after putting it into Redis, and we're basically scheduling each step as just a different task that needs to be run off of Redis, and we schedule a bunch of additional workers to just listen to this queue and see which jobs are available, and then execute those jobs. So as we're getting in raw data, we're sort of processing all of it as it goes on, as different sorts of workflows that are being run with different discrete steps. And depending on what the execution output of the previous step was, it will either schedule another job to be run. So let's say we find that a certain repository has been updated. Then we need to run the scan on the linguistic components to see whether or not this pull request was a new feature or a bug fix. If it was a bug fix, then we need to pull the repository and calculate the code differences. If these code differences are substantial and also in Python files, then we need to parse them into specifically structural changes or into the graph structure. And then from that graph structure, we need to then put it into our next batch for the raw input data. So really what we do at the last step is we're putting it into our like main database. We're keeping all of these code changes, but it's just like a set of binaries for individual sub patterns within the code that are related to the graph structure that was changed, along with some information about the raw code base itself and which commit it was. And we're basically associating different spans within here to the specific code changes. And then when we do training, or when we do the updates for the training, we are pulling like individual subsets from this database and waiting for the new ones more primarily. So we're getting all the new ones, plus we're getting some of the old ones, going through, doing a few more cycles, seeing if we're getting meaningful improvement. If not, then we actually take a couple subs back, start from a slightly further back checkpoint, go redo the training again with different groups, and depending on how the performance of the model is hashing out, we follow, or we select one of these trained models to then be moved into the actual production model for that week. And all of that stuff's being done semi-autonomously right now, and especially as we're going into doing more generalization of our model. That is, right now it's becoming more of a manual process, but we try and keep everything as automated as possible by making just different Python utilities to both like frame each one of these operations and run them within the cloud.
So you mentioned, you started off saying AWS and Terraform, and then you described the details of your automated stack, and you dropped a Redis in there somewhere. What specifically does your footprint look like on AWS in terms of, what regions are you in? What does it cost you? I mean, not specifics, but roughly, per month to run all the stuff that you're running. You know what I'm saying? Like just a overview of what it looks like for folks familiar with AWS in terms of implementation and implementation costs. And also, I'm a big AWS person, but I haven't used Terraform. I know what it is. I've also used Cloud Formation, which is similar. So,
Yeah,
anyway,
CloudFormation is basically AWS's internal Terraform, I guess you could say. It lets you define as code specific resources to put up into, uh, like, instantiate and set up different like rules for that. So it is similar. I do find that the main benefit of using Terraform versus something like CloudFormation is that you can always divorce AWS and keep all of your infrastructure. So you're not locked in, and
right.
that's something that I would definitely say is something that you should keep in mind as you're building out something on AWS, because if you get too attached to their specific resources, it can be difficult to scale if they make certain changes to what their pricing plans are, or what resources are available, or how things are going. And just, I mean, specifically for our application, because we also need to support people running it locally, or more particularly enterprise customers who want to keep everything within their own private cloud. We need to support those customers. So we need to keep it sort of vendor agnostic to some degree. So I mean, it's partially to our like fundamental requirements that we have something that's more usable across different vendors without necessarily being locked into a specific one. But while there isn't necessarily anything wrong with using all of AWS services, I do think that keeping some room to grow as like an independent entity is very beneficial in the long run.
No,
But that's
I love that. I want to terraform my way across cloud platforms. Now that you say that.
yeah. So it's definitely, yeah. I have already think I've left the original question, but I think what you wanted to see was what our footprint looks like. The footprint does heavily depend on what you're doing. Most of our costs are in EKS, so the Kubernetes platform. They have a managed service where they'll let you scale different nodes and do all that stuff for setting up Kubernetes. They charge for that in addition to letting you provision the nodes. So that's the most expensive component of it. We also spend less, but not an insubstantial amount, in doing the machine learning. However, this is a cost that is a bit harder to define because it really depends on how quickly you want to go. And I mean, it doesn't really even depend on how quickly you want to go, because like you can provision a lot of compute, but still not get too far in terms of accuracy or actual feedback or improvement if you aren't using like an appropriate technique that can take advantage of that. And even if you are using the appropriate technique, there's always like individual steps that need to be optimized. And a lot of that is bottlenecked mainly by the people and like the data science that you have working on those projects. So basically, depending on how much analysis we need to do, how many times we need to train the model, or how many parameters we want to search per week or per a particular time frame, we need to provision either more or less compute resources to run those training models. And right now, because we're using an LDA-based topic modeling system, LDA stands for latent decay allocation. I know those are like nonsense jargon words to most people, but basically it's a technique that doesn't scale very well with GPUs or any additional stuff. It's something that heavily relies on just having raw CPU computing power, but it also means that it doesn't parallelize very well, which means we all have to keep everything on one instance. So actually we have like provisioned one instance, or actually a couple of instances that have like 64 cores, and we're actually moving on to like 128 core CPU like model just to train this particular instance a little bit faster, so we can improve the turnaround time between starting an experiment and then seeing the results and then determining what needs to be done in order to improve the performance of this model. And when you start getting into like the very big single instances, the cost becomes very exponential. I would definitely not recommend doing that in the long term if you could help it. If you're using a technique that paralyzes very well, you should definitely provision a lot of small instances and then take them down after you finish each run. by using their API to do that. So you would basically set up certain rules to not restart instances if they close, or and then terminate the instances from inside of the instance itself. So you would set them up, run your application, have that application automatically set up to run by defining in Terraform, get the data from your data source that you're going to be keeping in like RDS or in Redis or something like that. So you pull in from your data source, also from the cloud, you do the operation, and then you would close down the instance at the end of the operation and then delete it after it's done. And then doing it in that way basically lets you build out a very robust analysis pipeline, do a lot of parameter searching, or like do a lot of training in different sorts of areas, aggregate all the results at the end of it, and then also provision some of these things individually. Within the application itself, we actually follow a similar model, but we leverage some Kubernetes native tools to do a similar thing. And I'm not sure if you guys are familiar with a service like kubeflow from GCP, but it also lets you do that from Jupyter Notebooks directly. And that's like a similar technique to
Nice.
what we're doing. Yeah.
And also, I assume I don't know if this applies to you, but to do whatever it is you need to do across different regions, US East 1 is notoriously terrible, and so sometimes you want to, for that reason or other reasons, do whatever your application is doing in, AWS regions at random.
Yes. You say US East 1 is like terrible. You would be. It's funny you say that because we actually are using US East 1.
Everyone uses US East 1.
Yeah, and that's probably why there's usually it's less stable than some of the other regions.
Sorry, it's about 11:15. Let's wrap up the technical and try to get to some Q&A for the rest for say another 15 minutes, and then try to wrap around 11:30. Just because I think folks start to drift off after an hour, and we're into our second hour. So anyway. Any non-technical stuff, Metabob, you want to throw in at the end here? Thanks again for doing this presentation, and you guys have a GitHub app so folks can go AI analyze their code with your GitHub app as we speak, if I'm not mistaken.
About that quickly, actually, if you end up using the application or trying it out, please, if you have some feedback, I'll drop my email in the chat. Please provide me the feedback as an email if you use the application, or if you want to just set up a meeting with me and try the application with me on a Zoom call, that's also possible. I'm happy to arrange that. I can send my Calendly link if you guys ping me on through email. So that would be really helpful for us to further develop the product.
Yeah, thanks again, guys. I really appreciate you making the offer to do this presentation and doing it and including all the technical. So let's do another 15 minutes of general QA, including Metabob, or just more AWS Python focused. And back to EC or US East 1. In addition to everyone using US East 1, I also heard recently that Amazon depends on it for some of their own services, which is a little disturbing. But just weird stuff tends to happen. I think recently I ran into I started using code build, and there was one day in particular where a code build that ran some Webpack, that would take a few minutes. Jobs were taking like 12 hours, and so this just like kills your workflow when you can't use the thing you're relying on. So that's not Python specific, but it's Python web specific, and if that happens to you, you're going to be very unhappy, as I was. And maybe being outside of US East 1 helps that, maybe not, I don't know. David, did you say you wanted to ask Daniel some questions?
Yes, I mean, well, the thing is that I know Python, I know data science with it, but I could use some ideas on how to get started training on a project that incorporates both Python data analytics as well as AWS. Like I have the AWS console open up right now. I started a CodeStar repository, but I'm not sure where to go from there as far as self-training is concerned. So that's why I'm interested in you and your experience. Like,
For data science and Python on AWS, Daniel, is that something you can address?
yeah,
If you're looking for something data science, I would say looking into something like SageMaker or something like that. I'm trying to deploy, if you work with data like machine learning and stuff, trying to deploy machine learning models on SageMaker versus setting up your own instances, trying to do it that way. But mainly, I would more recommend just taking a step back and just kind of looking into perhaps some like background on kind of what services are available and looking at kind of trainings related to that. I know there's like the certifications around like system architect, and then there's like the other cloud practitioner that kind of just gives you background and kind of gives you an idea what services are available, and you can, again, preferably learn stuff like CloudFormation as well to kind of, when you have ideas to leverage those services versus kind of clicking around in the console and stuff like that, to be able to display on your GitHub like everything in terms of kind of your code, your infrastructure, and stuff like that. So I think, sorry, I'm not too particular about like the data science stuff, so I'm not 100% sure.
yeah. My thing is they like their Python code a lot, but they said the other guy also had more AWS experience than me. I built a basic CodeStar website like a couple of years ago. That's why I'm trying to get more AWS incorporated into my data science, even though.
So, David, do you think that that they were looking for AWS in addition to Python, like not necessarily related to any Python data science you may do? Because that would make some sense. Or were they looking specifically for, like, did this other candidate have like super AWS data science experience? You know what I'm saying? Like,
No, they said that they really wanted a Python specialist, and they definitely gave me the impression that I'm a Python specialist and that I can handle all the Python tasks. But on my resume, I only have like a few years of AWS experience. I've done S3 buckets. I've messed with IAM. I've messed with CodeStar. I built.
IAM's a big one. I mean, stuff Meetup.
I never really on the job used it for too long. Outside maybe 6 months this one time. Python I used a lot more, and I came up as the Python specialist for them. But this other candidate also had more AWS in his background, apparently, in addition to also having the same Python levels. So that's why I'm trying to make sure,
The stuff that Avi and Metabob just described was what I would call data science on AWS. I mean, in a very broad sense. And so if you familiarize, based on their presentation with those technologies, that's probably going to be a good start. I mean, just offhand, I can tell you I have probably 10 years of AWS, and I started off just doing EC2 virtual machines, oh cool, I can have a computer in the cloud, and from there branched out to basically every other relevant service, including S3, RDS, IAM, CloudFront, CloudFormation, probably a few others. I hate the names they have for their stuff, but you really get Beanstalk. I'm a big Beanstalk user, not for any particularly good reason, just because I can deploy web apps with it, and if I want to use something else, the most likely candidate would be containers, and if I want to switch to that, then I have to take the time to get comfortable with a container stack, which is advantageous, and pretty much most everyone is doing that nowadays, versus say VMs for their applications. So just find something you can build and maintain on AWS for your own, educational purposes.
Yeah. Part
Sorry,
of
guys.
that also is
Sorry, Daniel. I need to go. So thank you again, Alex, for your time.
Thanks,
It was
Masi.
great meeting you all.
You too.
Yeah. Again, if you have any feedback, my email is just massi@meetup.com. And
Yeah, I will try it out and send you guys feedback, and I will upload this video if it's a video.
Yeah.
Maybe it's just audio. I don't know. We'll see.
Yeah.
To YouTube and send out the link.
Yeah, I can put also my LinkedIn on the chat if you want to connect again.
Sure.
Oh yeah, please do.
For everything. Well, I always love to do that. All right, guys, stay safe.
See ya.
Yeah. All right.
Yeah, I was just going to add, David, is just part of kind of knowing AWS is also just understanding their portfolio and kind of being able to, when you do push out something, kind of justify why you're using it. Like if you're kind of working with containers, what Avi uses is EKS, which is kind of specific to Kubernetes, but they also offer stuff like ECS and other services. Even like within ECS, you have the option of doing serverless with Fargate. And so it's kind of like knowing each of the particular niches that each of these services do and kind of be able to talk about why maybe something you went this way versus the other way and stuff like that.
Yeah, that's why I need to get better. I
Yeah.
feel like I know more. I probably know more about AWS than I think. I'm at that point in the, well, if you know the Dunning-Kruger effect between confidence and wisdom,
Yeah.
I feel like I'm in that middle point where I'm doubting everything that I think I know about it. So I probably know more than I think, but I can't say I'm an expert. But at the same time, I don't know. I'm at
It sounds like you just need to use it, like
Yeah.
make a blog or something and host it on AWS, and then all of a sudden you
Yeah.
have 10 years of AWS experience.
Yeah, exactly.
And also, like, I guess, learn the jargon.
Uh,
Like you need to talk
Yeah.
about ECS, the Fargate, all that stuff. Otherwise, it's going to be a bit more difficult, right?
Yeah, right now I added one other IAM user through other meetups. I have another person who's interested in learning Python through AWS. We were working together yesterday. This is why I was interested. If it's possible for me to like get some of your contact information and maybe because it would be at least one other person and maybe we could learn directly from you some tips or something like that. I don't know.
Who?
Avish, Avnash, Daniel,
Oh yeah. Sure, Avi, whatever, or whoever wants to just
Alex.
paste it in the chat.
Yeah, just place it in the chat. That way I can now introduce you to this other person because we're both trying to learn and get new jobs in this section. He was looking at me doing a lot of Python stuff and he was very interested in seeing what he can learn about Python from me, but we needed a sort of a mentor when it comes to integrating what we know into AWS. So I'm going to take everyone's contact here. Then maybe we can get another.
Also, Avi, if I learn Terraform, what's the next most obvious like cloud platform I could just go run and take all my Terraform to? Like,
Okay, so it's a bit of a personal bias. I kind of like GCP a little bit better in terms of what services they offer and like how things are set up, but it's also more expensive than AWS. So
Which
everything
one?
comes with a cost.
Google.
Google Cloud Platform.
Oh, interesting.
Yeah.
That is a surprise.
Yeah. I don't.
Sorry.
I don't know how better EKS has gotten recently, but always kind of when working with Kubernetes, there's always been a preference to go with GCP over AWS. I think that was my general perception. I don't know what EKS is like these days. I know.
I still think it's my general perception. We're mostly on AWS for one reason, and it's free credits that we get from some of our investors. So we're definitely enjoying that part of it.
Yeah.
Not needing to pay for it right now.
Here's
But,
what's funny about that is that I've applied for jobs, which I do quite routinely, even if I already have 10 jobs just for the interviewing experience. If you say I have AWS experience and they're looking for GCP, a lot of times they'll just be like, okay, cool. If you say you have one, that a lot of employers are willing to work with folks that have one and maybe very little of the GCP, which I have. And I actually hate Google Cloud, but not for any good reason. In fact, if based on what you guys just said, then it makes a lot of sense that if there's a particular service that one cloud does better, then I would like that as well.
Yeah, it kind of depends on what you're doing. If you're like an infrastructure engineer, obviously you need to have very in-depth specific experience with each like cloud provider, at least the ones that they're going to be using. But if you're like just a Python application developer, right? All you really need to know is that it's going to be running on a machine that's in a service or in the cloud someplace. So you need to understand more so the overall architecture about how things are going to be set up. So you need to know that, in this company, we're going to be using a container-based architecture. So you need to know how to build these containers, how they're hooked up to the rest of the application, what you need to do in order to get something built in in this type of style. So as long as you have a good understanding about, you know how to put things into EC2, and you know how like lambdas work, then you have a good general understanding. Like it doesn't really matter which cloud provider you're using because they all have similar offerings at this point. Like on Azure, you can set up something that's similar to lambdas that can run off of different particular things. There's serverless available as well. So all of this stuff can just be sort of like moved over here and there because they're all reaching the same parity. It's becoming more of a commodity, like using the cloud. It's less there's not as much like fashionability in it. It's more of just like, it's a base layer. You can do whatever you need to do on there. It's just something that's a bit more standardized at this point.
And with that, I'm going to wrap it up in a couple more minutes, but I will add this. I love that pipe. I love the pipeline of whatever it is you're doing. For example, on my web projects, I'll have a Jenkins, and so whatever you build locally, obviously, it's not going to run on the cloud, without some significant effort to make it so. But once you do that effort and you have a pipeline where all you focus on is the commits to your GitHub, and the automation does the rest to push it out to the cloud, then you're in a very good position. And I imagine that applies across the board. I mean, obviously it applies for Meetup building an application. There's data science pipelines that could, I think, take advantage of the same types of automation. And the other thing I wanted to mention in bringing that up was Google Actions, which is that what it's called? Google Actions, which now seems to be very popular in terms of providing continuous integration, or people are flocking to that too, because GitHub.
GitHub Actions.
Yeah, GitHub Actions, because people are GitHub is making that easy for them.
Actually, there's an offering on every SCM provider for GitHub Actions, quote unquote. Bitbucket has Bitbucket pipelines. GitLab has their CI/CD runner, and they all use the same structure. It's like a literal carbon copy between these different platforms. There's like a little bit of syntax differences, but it's just like, these are just commands that you're running on a container. Except they'll even provision the container as part of GitHub Actions. So all you need to do is just say, to build this thing, I need to run like npm install and then run webpack, and we're done. And you're there, you're done. Or I need to do like pipenv and set up the environment, get all the dependencies, and do all that stuff. All right, and it doesn't really matter what you're using or where it is. It just sets it up like in an automated way.
Just like sorry, go ahead.
Oh, no, I'm just saying that's sort of where everything's going nowadays.
Just like Microsoft Edge seems to be the same browser as Chrome. What's going on there? Yeah. All right, folks. Appreciate everyone's time. Thanks for joining. See you in a month. And David, hit up.
Yeah, I think I'm going to get in contact with my other friend, and maybe within the next couple of weeks, we'll see if we can't host this meetup that will work for everybody, and then we can all get. Because when I do a meetup, I like to have a screen share session where I start coding, and I just a partner programming session.
Why don't you do this meetup next month?
Yeah. So I'm thinking about because I have my AWS console up right now, and yesterday I at least created the code star repository for it. Now to make it do something.
Yeah, I got you. You want like a project night, which I think we have.
Yeah,
online.
and I need somebody to backseat. I would love to have people like you guys just backseat program while I actually type up everything. I think that would be the best way for me to learn right now. Just have somebody say, "Do this." Okay, next you do that, and then I have to figure it out. Then you guys tell me, "No, not that one. The other one."
All right. Well, because I'm lazy, let's tentatively schedule that for
Anyway, so yeah.
to
Hopefully
next month's.
and yeah, I'll let you guys know. Okay.
All right. Thanks, everyone. See you next time.
All right. Thank you so much. I really appreciate it.
Bye.
Thank you. Appreciate it.
Bye-bye.
Thanks, everyone.